Welcome to our exploration of semiconductors, the unsung heroes powering the modern world. From smartphones to cars, semiconductors are at the heart of countless devices we use every day. But what exactly are they and why are they so crucial? In this video, we'll break down the basics, uncover their unique properties, and explain how they've become the foundation of our digital age. Let's start by understanding what makes semiconductors so special and how they differ from other materials. Semiconductors are materials that have electrical connectivity between that of a conductor and an insulator. This means they can sometimes allow electricity to flow, but not always, making them incredibly useful for controlling electrical signals. Silicon is the most famous semiconductor, but there are others like germanium and gallium arsenide. Their ability to switch between conducting and insulating states is what makes them perfect for building electronic circuits. Let's dive deeper into how this property is harnessed in technology. Silicon is the backbone of the semiconductor industry. Found abundantly in sand, silicon is processed and purified to create wafers that serve as the foundation for microchips. These chips are then etched with intricate circuits, enabling them to perform complex tasks. Silicon's unique properties make it ideal for controlling electrical currents, which is why it's used in everything from computers to solar panels. Its versatility and reliability have made it the material of choice for decades. Semiconductors operate by manipulating the flow of electrons. By adding impurities, a process called doping, engineers can control how and when electricity moves through the material. This ability to switch on and off is the basis for transistors, which act as tiny electronic switches. Transistors are the building blocks of all modern electronics, allowing devices to process information, store data, and communicate. Understanding this process is key to appreciating why semiconductors are so vital. Transistors are the fundamental components inside microchips. Each chip contains millions, sometimes billions, of these tiny switches. When grouped together, they form logic gates, which are used to perform calculations and process information. The miniaturization of transistors has enabled the rapid advancement of technology, making devices faster, smaller, and more efficient. Without transistors, modern computing would not be possible. Semiconductors are everywhere. They're inside your smartphone, laptop, television, and even your car. These materials enable devices to process information, connect to networks, and perform tasks efficiently. Whether you're streaming a movie, sending an email, or navigating with GPS, semiconductors are working behind the scenes. Their presence is so widespread that it's hard to imagine modern life without them. Smartphones are a prime example of semiconductor technology in action. Inside every phone are multiple chips, each responsible for different functions, processing, memory, connectivity, and more. These chips rely on semiconductors to operate efficiently and reliably. The evolution of smartphones has been driven by advances in semiconductor manufacturing, allowing for more powerful devices in smaller packages. At the heart of every computer lies a microprocessor, a complex chip made from semiconductors. Microprocessors execute instructions, manage memory, and handle input and output. Their speed and efficiency are directly tied to the quality of semiconductor materials used. As technology advances, microprocessors become faster and more capable, enabling new applications and experiences. Modern vehicles rely heavily on semiconductors. From engine control units to infotainment systems, semiconductors manage everything from safety features to navigation. Electric vehicles in particular depend on advanced chips to optimize battery performance and control motors. As cars become smarter and more connected, the demand for semiconductors continues to grow. Healthcare technology has been revolutionized by semiconductors. Medical devices such as MRI machines, pacemakers, and diagnostic tools rely on chips to function accurately and safely. These devices process vast amounts of data, monitor patient health, and enable remote care. Semiconductors ensure reliability and precision, making modern healthcare possible. Renewable energy systems such as solar panels and wind turbines depend on semiconductors to convert and manage energy. Chips regulate power flow, optimize efficiency, and protect equipment from overloads. As the world shifts toward sustainable energy, semiconductors play a vital role in making these technologies reliable and affordable. Communication networks, including the internet and mobile systems, rely on semiconductors to transmit and receive signals. Chips in routers, satellites, and cell towers enable fast and reliable connections. Without semiconductors, global communication would be slow and unreliable, making them essential for our connected world. From gaming consoles to streaming devices, semiconductors power the entertainment industry. Chips process graphics, sound, and video, delivering immersive experiences. Advances in semiconductor technology have enabled high-definition visuals and realistic gameplay, transforming how we enjoy media. Artificial intelligence relies on powerful chips to process massive amounts of data. Semiconductors enable machine learning, facial recognition, and natural language processing. As AI becomes more advanced, the demand for specialized semiconductor chips grows, driving innovation in the industry. Space missions depend on semiconductors for navigation, communication, and data analysis. Chips in satellites and spacecraft withstand extreme conditions, ensuring reliable operation. The exploration of space pushes the limits of semiconductor technology, leading to breakthroughs that benefit life on Earth. Security systems, from surveillance cameras to biometric scanners, rely on semiconductors for fast and accurate processing. Chips enable encryption, facial recognition, and real-time monitoring. As security needs evolve, semiconductors provide the foundation for safer environments. Industrial automation relies on semiconductors to control machinery, monitor processes, and ensure safety. Chips in sensors and controllers optimize production and reduce waste. As industries become more automated, semiconductors drive efficiency and innovation. Banking and financial systems depend on semiconductors for secure transactions and data management. Chips in ATMs, payment terminals, and servers ensure reliability and protect sensitive information. The rise of digital banking has increased the importance of semiconductor technology in financial security. Logistics and supply chain management use semiconductors to track shipments, manage inventory, and optimize routes. Chips in sensors and tracking devices provide real-time data, improving efficiency and reducing costs. As global trade expands, semiconductors play a key role in keeping goods moving. Modern agriculture uses semiconductors in sensors, drones, and automated machinery. Chips monitor soil conditions, control irrigation, and track crop health. These technologies help farmers increase yields and reduce environmental impact, making agriculture more sustainable. Educational technology, from tablets to interactive whiteboards, relies on semiconductors for fast and reliable operation. Chips enable online learning, digital textbooks, and virtual classrooms. As education becomes more digital, semiconductors support new ways of teaching and learning. Home appliances, such as refrigerators, washing machines, and smart thermostats, use semiconductors to operate efficiently. Chips manage energy use, automate functions, and connect devices to the internet. Smart homes are made possible by advances in semiconductor technology. LED lighting is powered by semiconductors, offering energy-efficient and long-lasting solutions. Chips control brightness, color, and timing, making lighting systems smarter and more adaptable. The shift to LED technology has reduced energy consumption worldwide. Wearable devices, such as fitness trackers and smartwatches, rely on semiconductors for processing and connectivity. Chips track health metrics, sync with smartphones, and provide real-time feedback. The popularity of wearables has driven innovation in semiconductor design. Robots use semiconductors to sense, process, and act. Chips enable precise movement, object recognition, and decision-making. As robotics advances, semiconductors make machines smarter and more capable, transforming industries from manufacturing to healthcare. Audio devices, including speakers, headphones, and microphones, rely on semiconductors for sound processing and amplification. Chips deliver clear audio, noise cancellation, and wireless connectivity. Advances in semiconductor technology have improved the quality and versatility of audio equipment. Digital cameras and smartphones use semiconductors to capture and process images. Chips manage sensors, autofocus, and image stabilization, producing high-quality photos. The evolution of photography has been shaped by advances in semiconductor technology. Gaming consoles and PCs rely on semiconductors for graphics processing, speed, and connectivity. Chips enable realistic visuals, fast gameplay, and online interaction. The gaming industry continues to push the boundaries of semiconductor performance. Transportation systems, including trains, airplanes, and ships, use semiconductors for navigation, safety, and communication. Chips manage sensors, control engines, and ensure reliable operation. As transportation becomes more advanced, semiconductors are essential for efficiency and safety. Future of semiconductors is bright. As technology evolves, new materials and manufacturing techniques are emerging, promising faster, smaller, and more efficient chips. Innovations like quantum computing and flexible electronics are on the horizon. Semiconductors will continue to power the devices and systems that shape our lives, driving progress in every industry. Their impact is only set to grow, making them more important than ever.